Greetings class, I'm Innocent MAPANDA. I hope I find you well. In today's lesson, we're going to be focusing on differentiation from the first principle, right? We are given f of x is equal to x cubed minus 6x, and the examiner is asking you to find the derivative of x cubed minus 6x, but using the first principle. So remember, we are used to differentiate algebraic expressions of this kind using the power rule. And according to the power rule, let's say you are given f of x, right, is equals to a x to the power of n, something like this. You multiply a, the number, with the power n, you get a n. Then you less the n with 1 to find the new power. I hope you are following. Like here, you are saying there is a silent 1 on x. So you are saying 3 times 1, you get 3. But you less 3 with 1. I hope you are following. Then there is a power 1 on x. So you are saying 1 times minus 6. You get minus 6. Then this 1, you less it with 1. You get 3x squared minus 6x to the power of 0. But according to the laws of indices, any number raised to the power of 0, you get 1. Meaning to say you get 3x squared minus 6, which is your answer, or which is your first derivative, but using the power rule. I hope you are following. Right, so the examiner this time around is not asking you to use the power rule, but they want you to use a derivative from the first principle. So if you answer this question using this way, you are wrong, because they want you to use the first principle method. But if we use the first principle method, still we are going to get the same answer. 3x squared minus what? Minus 6. So I want you to pay attention as I use the first principle method. Right. So according to the first principle, you are saying derivative of f of x, you have a limit, right? You have a limit which is x approaching 0, something like this. Then you are saying fx plus h minus f of h, right, all over 2 to a. So this is the formula that you make use of. I hope you are following, right? So what I'm going to do is I'm going to substitute f of x plus h in the original function x cubed minus 6x. So if I move to the next stage, you get, start by writing your limit. H is approaching 0, something like this. Then you take x plus h, then you insert it on x cubed minus 6x. So you get x plus h to the power of 3 minus 6. Then you get x plus h if you put it on minus 6x. Then you are going to less with f of x. So f of x, it means I'm going to paste and copy the original function x cubed minus 6x as it is, but do not forget to put the bracket. So you write minus x cubed minus 6x, but make sure you put it in brackets, because this negative sign is affecting both x cubed and minus 6x. I hope you are following. Right, so I want you to notice something, class, that from this bracket, x plus h to the power of 3 minus 6, open bracket, x plus h, from this point up to this point, this result is representing f of x plus h. I hope you are following. Then x cubed minus 6x is representing f of x. So the difference of f of x plus h minus f of x, you get your numerator according to the formula above. I hope you are following. Then you are going to divide everything with h, something like this. Let us proceed. Right. So at this stage, we are now expanding this bracket x plus h to the power of 3 using the binomial expansion or the Pascal. Right, so according to the Pascal, if the power is 3, the coefficients are 1, 3, 3, 1. If you have a power of 3, you have the coefficients as 1, 3, 3, 1. So let me expand this. X plus h to the power of 3. I'm going to write 1. Then you put 2 brackets in front of 1 plus 3. Then you put 2 brackets plus 3. Then you put 2 brackets plus 1. Then you put 2 brackets, something like this. So in the first bracket, I'm going to put x here, which is your first term, raised to the power of 3. Then here you put h raised to the power of 0. So the powers of x are going to decrease, whilst the powers of h are going to increase. Meaning to say, in this bracket, you have x squared and h to the power of 1. Here you have x to the power of 1, 2. Then here you have x to the power of 0 and h to the power of what? 3. So the powers of x are decreasing, whilst the powers of h are increasing. Right, so if we simplify this bracket, you get x cubed. Why? Because any number raised to the power of 0 is 1. Then you say plus 3 x squared h, which is your second term, plus 3 times x times h squared, you get 3x h squared. Then here you'll be left out with the h to the power of 3, since x to the power of 0 is 1. I hope you are following. So I'm now substituting this expression on x plus h to the power of 3. So let us proceed. So I'm going to write derivative of x is equals to, you maintain your limit, h is approaching 0, something like this. You have x cubed plus 3 x squared h plus 3x h squared plus h to the power of 3, representing this bracket. Then let us expand. Minus 6 times x, you get minus 6x. Then minus 6 times plus h, you get minus 6h. Then minus times x cubed, you get minus x cubed. Then minus times minus 6x, you get plus 6x. Then you divide everything with h. Right, so at this stage, you can notice that there are terms which can cancel off each other. I hope you are following. Like positive x cubed is going to cancel off each other with negative x cubed. I hope you are following. Then negative 6x cancels off each other with positive 6x, something like this. So it means on our, let me write my limits here, h approaching 0. It means on our numerator, you'll be left with 3 x squared h plus 3x h squared plus h to the power of 3 minus 6h all over 2h, something like this. So let us distribute the denominator h on each and every term on the numerator. I hope you are following. Let us write the limit. H is approaching 0. H and h, they cancel off each other, leaving you with 3 x squared as your first term. Then h into h squared, you get h. So the second term becomes 3 xh. Then h into x cubed, you get h squared minus h and h, they cancel off each other, leaving you with a -6. Right. So at this point, we are now substituting the limit h is equals to 0. I hope you are following. Putting 0 on h, 3x h becomes 0, and h squared becomes 0. So you'll be left out with 3x squared minus 6, and this is your final answer using the differentiation from the first principles. So this answer is matching with the answer that we get when carrying out the power rule. But it is very important to know the first principle, because the examiner may ask you to differentiate using the first principle. And if you use the power rule approach, it means you will get it wrong. I hope you enjoyed today's lesson class. I'm Innocent MAPANDA, and thank you for your support. Till we meet again, Shalom.